Alright, so here's the problems that you were supposed to do from Friday night. For this, we knew that this was a vertex. So what form did we say we were going to write this in? So give me the generic form for vertex. It should be f of x equals a times the quantity is the way you say that, just so you know for later on. Whenever you want parentheses, you say times the quantity. X minus h, all of that squared plus k. Now, on Wednesday, you're going to have to know that on your own. That will not be given to you anywhere on the quiz. What is this right here? What is the 6? It's the h. What is the negative 75? What is the 0? X. And what is the 15? And you are just going to plug into those spots. What do we really think f of x is? So it should be 15 equals, we don't know what a is, that's what our job is. X was minus 6 squared. Now you could do plus a negative 75, or how else could you write that? You could just write this as a minus 75 or a plus negative 75. I don't care which way you write it, doesn't matter to me. Everybody good so far, which is the plug-in phase of this. Now, just simplify. 0 minus 6 is what? Negative 6 squared is, so is everybody okay with me writing this as 15a, or 15 equals 36a minus 75. Now this is just a two-step equation from chapter 2 or 1 of Algebra 1. Add 75 to both sides. Add 75. 90 equals 36a. What do I do next? Divide by 36. Divided by 36. If you don't see that the biggest number in this is a 12, 12 go into it? 12 go to 90? What is it? 3, 9, 18. If you don't see that 18 is the biggest number that goes into this, that's okay. How can I reduce this? What number do I know goes into both of them? Let's pretend I don't know it's 18, is what I said. I know 2 would, I know 3 would, I don't care which one you start with. I'm going to start with 3 because that's where I would like to go. Is everybody okay with that? So 3 goes into the top, 30, over, 3 goes into this, 12 times. And then I look at that number and I go, is there anything else to come? Yeah, what else goes into 30 and 12? 3 again, and what do I get? 10 over, 3 goes into that, 4. Is there any other number that still goes into it?
2.
Yes, 2. And so I end up with 5 halves equals a. Does everybody understand how I reduce that fraction? Now, if I would have seen that 18 went to both of these right away, I would have got to the 5 halves right away. But again, you don't have to do that. You could just be breaking it down slowly. You do need to get to this. Do not write this as a decimal. Do not write this as a mixed number. Mixed numbers were good for back in the day because if I go to Home Depot, and I'm going to buy 5/4 of something, I'm going to look pretty stupid if I tell the person I need 5/4 of it. Maybe not. But if I need 5/4 of something, what do I really know I need? I need 1 whole and 1/4 of another of something. So that's why in middle school, whenever you saw an improper fraction, they forced you to change it to a mixed number so that you actually knew what an improper fraction really meant. But as far as math goes, can you add really an improper fraction with another fraction really easy? Or what do you first change it to? What do you first, can you change, well, you don't have to, but what can you change that to? Improper, and then you can add them, right? What about multiplying? For sure with this one. Can you multiply this times 2 and 3/8? What do you have to change this to before you can multiply it? Improper. What do you have to change this to before you can multiply it? So guess what we do when we get to higher level maths? When we get a, and it's an improper fraction, guess what we do? We leave it as improper because it's much easier to deal with when it's improper. We don't have to change it and do anything else. And I'm okay with knowing that that is really 2 wholes and a half. So I know that from middle school because they forced me to change it to that, but I'm not going to write it as 2 and 1/2. I'm going to leave it as 5/2. Is everybody comfortable with what I'm talking about here? So if I want to write this equation, it would be f of x equals, I need the a plugged in, so 5/2. X stays x minus 6 squared, don't forget that, minus 75. That should be your answer, and that's what I'll be looking for on that quiz come Wednesday. You will have 2 questions just like these. What do you think the first one's going to be? Vertex form, right? What do you think the second one on your quiz is going to be? One of each. Does that make sense? Yes.
Yeah. Wouldn't you need to find the x-intercept? Because it would just be equal 0.
Well, not for this. Vertex form. Vertex form, I only need A, H, and K. And I look over here, they gave me H and K. What am I missing? My A. This over here is the whole, all this over here is how to find A. There's no other way to do that. Alright, so for B, what form is this one going to be good for? Factored. How do we know that? Because they gave us our x-intercepts, right? So we'll do this one in green. What do I know this one is? R1. What is this? And what is this? And what's my factored form look like in generic? F of x equals A times the quantity x minus R1 times the quantity x minus R2. You have to know that before you can be able to plug anything in. This really stands for what? So what gets plugged in there? 6 equals, do I know what A is? Times, what's my x value? And actually, how many times am I going to write 4 in this one? Twice, right? Minus, does this have to be R1, by the way? No, it's just easier if I just think of that. So R1 would be 2 times quantity 4 minus 8. Does everybody understand where all those values are coming from? Again, what's the lone value that's not written in for? A, because I need that. I need to solve for A. So 6 equals 4 minus 2 is 2. 4 minus 8 is a negative 4. And so I get A times 2 times a negative 4. Everybody okay with that? 6 equals negative 8A. All I did was 2 times a negative 4. Now what do? Divide by A, negative 8. Divide by negative 8, and I get A equals, do you see that 2 goes into both of these? So I can reduce that to a negative 3/4. Is that my answer? Am I done? No. What does the question want me to write? The equation. So I go f of x equals A, which is negative 3/4, x minus R1, which is 2, x minus R2, which is 8. And there is the answer to that question. What do we think? One common mistake that I saw on, which one did you do also? It was F?
Yeah.
One mistake that I saw was something like this. It was like -2 equals 14a. One common mistake that I kept seeing is people did this. And they would go a equal -7. How did they do that? Because they switched, and this is not just this period, this was first period also. 2 divided by 14, what did they think in their head? 14 divided by 2. You can't do those silly mistakes. This is really 2 divided by 14. What do they both have in common? A 2. So it should become 1/7. Should have been your A for that one. And that's a -1/7. I believe, right? Was it -1/7? Yeah. Okay. Yeah. All right, so we should be on this page. We're going to go through 2.3. We're going to talk about vertical dilations. Vertical dilations are going to be what we call both of them, but really what we're going to be focused on is really knowing if they're vertical stretch or vertical compressions. Not too much involved in this section. It won't take us too long. I'm not going to go too deep into this. So here we go. We're just going to really go to this point right here. So right here, if I went and I made X and Y chart for these guys, we're going to do this one in red. So we're going to make an X and Y, and I'm going to try to put this as best I can. If I put a 1 in for X, what do I get out? Put a 1 in here, what do I get out? A 2, right? 1 squared is 1 times 2 is 2. So my first order pair would be 1, 2. So if I go over here, this graph, which is the normal one, which is X squared, goes 1, 1. So it's right there. Notice what happened when I put the 2 in. It became 1, 2. What happens if I put a 2 in? You're going to see a really big jump here. 2 squared is 4 times 2 is... So all of a sudden I went over 2, and now I'm all the way up to 8. And if I mirror that, it would be right here. If I mirror that one, it would be right here. And so my vertex still, I haven't moved it right or left. That's what we talked about on Friday. So does everybody see this graph? What did it get? Oh, got narrower, got skinnier. Let's jump to this one. Let's jump to this one. Let's make an X and Y chart for this. If I put in a 1, what do I get out now? 4. So if I go over here, now I'm at 1, 4. What if I put a 2 in? I get 16. Which isn't even up here, right? Because 2, 4, 6, 8, 10. So 12, 14, 16, maybe somewhere up in this region. And if I mirror that, it looks like this. What happened when that became a 4? What happened? My graph got even more skinny. Pretend that this thing right here is a rubber band. Pretend it's a rubber band. What happened if I pull on the top of a rubber band? What's it going to do? It gets more narrow, right? And what would I be doing to the rubber band? What would you call that? Stretching it, which is why this is called a vertical stretch. Now that's going to be known as a vertical stretch because it's literally like you are pulling on the top, you are pulling on these things right here, you're pulling right here, and you're pulling it up. And that's what's forcing it in and making it skinnier, just like a rubber band. Vertical stretch. Does that make sense? What are your A values when you have vertical stretch? Anything greater than 1. Yeah, I would. I don't know why they put that. I don't agree with that. Because if A is 1, then I don't really have a stretch or compression. It's just my normal guy. It's just my normal, the way that my parent looks. If I have a stretch, it's going to be anything bigger than 1. Then it's going to look a little bit different. And the further it gets away from 1, the further it's going to get away from looking at the parent, meaning it's going to get skinnier. You with me? Now, what do you think we're going to call this down here? Call this a vertical what? Remember the 2 words that we had? Stretching and compression. Remember that rubber band I told you about? So pretend you had a rubber band. And it's like this. And it actually holds its shape. So we got a nice, that's a beautiful rubber band. What happens if I compressed it? Doesn't that mean I'm pushing down on the top? What would happen to a rubber band if you pushed it down from the top? What would it do? It would start to get like that, right? Notice that instead of looking like this, like my parabola, what would happen is it would start to look more wide if you had a compression. Does that kind of make sense? Now, obviously, you know that a rubber band is a circle and a parabola is not the shape of a circle, but do you get the idea, the picture of what I'm trying to draw from it? Okay, so this is called a vertical compression. And if we did this graph right here, make an X and Y chart. Let's just see what happens. If you put a 1 in, is that going to be a good number to use? Remember, who gets to pick these numbers? So if I pick 1, is 1 a good number? Why? What do I end up with? A 1/4. Do I really want to come over here and graph a 1/4? I get to pick. If I put a 2 in, wait, why skip 2? What's 2 squared? 4. What's 4 times a 4th? Everybody with me? So if I go 2, I only go up 1. So notice I went over 2, but now I only get to go up 1. Last time, on my parent, when I went over 2, I went up 4. Do you see how it's going over farther and going up less? Do you see how it's going to get wider? Would 3 be a number that I would want to use for this one? No, what would be a good number? So if I use 4, 4 squared is, but 16 times a 4th is only. So if I go over 4, now I only get to go up 4. Do you see how this graph is getting wider? And I could mirror that. Back 2, up 1, back 4, up 4. And there would be my, do you see how it's getting wider? Notice, what did I not talk about A being? So where did it never go for vertical stretch or compression? It never worries about your negative version. So here's what I mean. If you have a negative 2, what does the and this is my, so if my A equals negative 2, what does the negative part tell you? What does the negative part tell you? Has nothing. The negative part has nothing to do with stretch or compression. All the negative tells you is a concavity, which tells you that this is going down. And what does the 2 part tell you? That it's a stretch by 2. Are you with me? So if I had A equals a 1/4, what does that tell you? Since it's a positive, since there's nothing there, it's a positive, I know it's going up, and it's a compression by 1/4. That's why these things never talk about A being negative, because A being positive or negative has nothing to do with whether it's a stretch or it's a what? Compression. Notice, you're not allowed to say A for, you're not allowed to say this for compression. You're not allowed to say A is less than 1, are you? Because what would that mean? My negatives would also be considered a vertical what? Compression, and they're not. Being negative has nothing to do with whether it's a stretch or compression. Being negative tells you the concavity. Being bigger than 1 or between 0 and 1 tells you with compression. Are you with me in understanding that? So here's what it's going to look like on your quiz. Here's all you really need to worry about. By the way, does everybody understand about how this plugging in and figuring out what y is? We really need to understand that idea of plugging in, because eventually you're going to have to graph one of these all on your own. And I'm going to have a whole bunch of stuff on it. Here's what it's going to look like on the test, and then here's how you're going to use it for later on. Test question is going to look like this. F of x equals negative 4x plus 3 squared minus 7. It's going to ask you, what is the horizontal shift? Well, that's from Friday's lesson, and that's in here. What does a positive 3 tell you? That it actually moves left 3. Remember, from Friday, inside moves the opposite way you think. So it actually moves it to the left 3. What does the positive 7 tell you? Or I mean a negative 7, sorry. What does the negative 7 tell you? Better watch Friday's lesson a little more. This says down 7. That's what we did on Friday, talking about how does this move and how does this move. This moves opposite the way you think. This moves the way you think. Now, what does the negative tell me? That it's down. Concavity is down. And what does the 4 tell me? That it's a stretch, which means it's going to get skinnier by 4. That's what you're going to have to do. And that's called a vertical dilation. These are called, this right here is called a vertical shift. Do you see the difference between them? Now, when I go to graph this one, hold on one second. When I go to graph this one, here's what this tells me. You see that I know it's left and down to my vertex? So before I even draw this, I already have an idea of where it's going to go. And I know it's going to be like this. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. I know my vertex is going to be there. Because that's, remember, my vertex for my parent is here. If it goes over 3 and down 7, boom, I know that's where my new one's going to be. And I know it's going to be facing down, so I know it's going to be doing that. And I know it's stretched, so I know my normal parent looks like this. What do I know about this one? It's going to be really skinny. So when I graph this, it's better follow all those characteristics that I already have in my mind. Do you see how this can help you out when it comes to graphing? Questions? Yes? This is only going to be for vertex form. Yep. Yes, very good point.